Welcome back to CodingCraft. Today, we tackle a deceptively tricky problem: how to remove k digits from a number and still make it as small as possible. At first glance, it feels like greedy chaos, but with a monotonic stack, we'll turn it into a clean, linear time solution. Here's the challenge. You're given a number as a string and an integer k. Your goal is to remove exactly k digits so that what's left is the smallest possible number. You can't rearrange digits, and you can't leave any leading zeros unless the result is literally just 0. In this example, we remove 3 digits from 14322219 and end up with 1219. Let's see what happens if we try the naive way. So what if we just try every possible way to remove k digits? Sure. We could try all combinations and keep the smallest result, but that leads to a combinatorial explosion, sea of n choose k possible versions. It's totally impractical for large inputs and can easily time out or crash. In this example, removing 3 digits from 14322219 leads to a branching mess of possibilities, and we're only scratching the surface here. There must be a smarter way. Here's the smarter way: a monotonic stack. Instead of trying all combinations, we make local greedy decisions. We remove digits that are larger than the current one, but only if we still have removals left. This ensures the stack remains in increasing order. Why? Because bigger digits on the left hurt us more. Removing them earlier leads to a smaller final number. Each digit is pushed and popped at most once, giving us a clean and efficient O of n solution. Here's the final Python solution: clean, concise, and built for performance. We loop through each digit in the number. If the current digit is smaller than the top of the stack, and we still have removals left, we pop from the stack. This ensures we remove larger digits early and maintain a growing, minimal result. After the loop, if we still have digits to remove, we pop from the end. Finally, we join the stack, strip leading zeros, and handle the edge case where the result is an empty string. Every digit is pushed and popped at most once, giving us a true O of n solution. Let's wrap it up. We saw how brute force fails due to combinatorial explosion. But with a monotonic stack, we get a clean, linear time solution, pushing and popping each digit at most once. This greedy strategy builds the smallest number step by step, and it scales even on large inputs with elegance. Up next, we'll tackle the 132 pattern and other stack-based problems. You can also check out our shorts on the next smaller element. Make sure to subscribe, explore more on the channel, and find the full code on GitHub. Thanks for watching, and see you in the next video.